Deploying Synergy with Kubernetes session. My name is Philip Bratt. I'm joined by our presenter today, Synergex's Chief Technology Officer, Jeff Green. For those of you who missed Jeff's bio earlier this week, so Jeff joined Synergex in 2006. He brought his passion for open source and standards-based technologies with him. His first contribution to our product suite was Synergy DBL integration for Visual Studio, which is amazing, for which he has architected and implemented items involving IntelliSense debugging and migration tools. He championed the importance of running Synergy on .NET Core and was the lead developer on that project. Jeff has been instrumental in Synergex's embrace of service-oriented architecture, or SOA, and standards-based technologies. So we will be getting on with the session, but there will be time for a Q&A after the presentation with an opportunity to use your mic if you wish. In the meantime, be sure to post questions to our Q&A or chat area on your screen. And then for any technical issues, if you're having a hard time seeing this or there's any problems with the stream, be sure to contact classes@synergex.com.
Hello, I'm Jeff Green, Synergex Chief Technical Officer. And you've seen or will hopefully see us talk about containerization and Kubernetes quite a bit this conference. This talk will have some overlap with others, just on the edges, but mostly I'm going to be talking to you about the slightly less glamorous day-to-day concerns involved in deploying Synergy applications using containers, or more specifically, Kubernetes. So here's sort of a quick Cliff Notes version of why this might be good for your application. There are a lot of Kubernetes users out there today, and between Kubernetes and just generally containerization, it's for a good reason. These technologies solve real-world problems that actually impact developers' lives. Over the years, I've heard a lot of stories from Synergy devs about how they manage upgrades in production. And this seems to always fall into one of two camps. Either you have planned outages on a Sunday at 1 a.m., or you slam it in on a Friday night, 8 p.m. to 10 p.m., and hope nothing goes wrong. I don't know about all of you, but I really like being asleep at 1 a.m. on a Sunday, and I enjoy not working late on Friday nights. So clearly, there's some room for improvement here. Being able to deploy in your production environment without actually switching users over to a new deployment is a game changer for your Friday night plans. If something goes wrong, you can just roll everything back to the way it was before your deployment happened. That's really the magic of containers. On top of the benefits directly to you, the developers, there's also things like auditable deployments. Because your containers are nice and packaged up, and your configuration is just data, regulators and security specialists don't have to dig nearly as deep in order to find the answers they need. Imagine walking into the house of a hoarder, your old server in this analogy, versus walking into a well-managed library. There's still probably the same amount of stuff between those two places, but one is really well organized in comparison to the other, definitely. It's just a lot easier to find everything when there's a table of contents to lead you around. And here's just a quick demo of the RCC application deployed and running in Kubernetes. What I have here to demo is really just another view into the demo that you saw in Kelsey's presentation. So it's still the same exact containers. It's pretty similar YAML, but it's being deployed to a Kubernetes cluster that's running in a couple of virtual machines on my desktop PC at work. So I have a couple of these VMs in here, and they're my local Kubernetes cluster. So as for the YAML, it should be a little bit familiar at this point. There's a persistent volume of some sort where the data is stored. There's a persistent volume claim that says how this thing actually works and what its name is, what size it is. and then the service. So there's a load balancer here that sits in front of the RCC API. And in this example, we're only using one node at a time. So it's not that it's actually load balancing, but it provides a jumping off point. So if the API moves from one node to the other, even though it's only ever running on one, that the load balancer can move with it and point to the new correct location. Also, it's how you expose things out through Kubernetes. So I have a service here for the HTTPS side, and I have a service here for the SSH side running on port 2022. And then we have the RCC API container itself, along with configuration. The RCC engines, so those are the background services that process the engine queues where requests come in and then they get operated on. And lastly, the RCC client itself. So this is what is running SSH, and there's a Synergy DBR in there that we launch immediately on connection, and that is what you can think of as the RCC client application. There's web front-end components as well, potentially, but this would be sort of the traditional RCC client. So I have my Kubernetes cluster set up, and I have a couple of nodes, and there are no pods set up. Should be empty. So I have this YAML file, and I can apply it. And everything will get created. And I can go check on the status of that. And everyone's up and running now. So that means I should be able to putty in and see our RCC application. And here we are. So it looks like a typical Synergy application, menus and little windows and all the sorts of goodies that you expect from these things. So I can interact with stuff, have it go do things, pick items, back out. So I'm sure. And just the basics, they are here and they are working. So beyond that, that's the client. The API is also running. So we have a Harmony Core web service that's running in this same environment, and I can get at that. I have to get, so this is the cluster IP address. So this is sort of the front end of this cluster that I'm running. So I can send my request in to get a login token, and I'll go grab that token and use it in my next request. And so now I get RCC API data back, and I can do this in the other one I have here, and we can get back actually that same record that I was looking at in the RCC client, that last name ASDF lead. So this is that same record, just looked up a different way. And a lot of the Kubernetes demos you see out in the blogosphere or on Twitterverse really just kind of punt on the topic of data storage. Either they'll use some cloud provider's managed database, or they just sort of hand wave it away and make it kind of a stateless application somehow. This is really more of a lack of imagination on their part. Kubernetes has no problem dealing with persistent data. There are a few things that need to be managed around your data, though, in order to have the kind of service uptime that's expected in these environments. My discussion of persistent data is going to be focused on Synergy DBMS or ISAM files. But if you use SQL Server or something like that, you can find countless other talks about working with these sort of tools in Kubernetes. If that's your scenario and you're looking for a little reassurance on the Synergy specific parts of that equation, feel free to reach out to professional services for assistance. I don't think generally devs love this part of the conversation, but we do need to go over the basics of handling your Synergy licensing in a containerized environment. So I'll go over the current state of things and what you need to do. And finally, I'll bring up platform support, where you can actually run this stuff. So this is about resilient files, and I basically stole this slide from Steve's Synergy update session at last conference, because it's an important enabling technology in this environment. In version 11, we introduced support for resilient ISAM files. You can turn on this feature when you're creating your files from XDL, or you can toggle it in your existing ISAM files using isutil-p. The purpose of this is to automatically detect and repair index corruption without significant disruption to the users of the system. An enormous amount of effort went into making this recovery process very fast, and as a result, it will take advantage of whatever hardware you throw at it in order to get the job done quicker. Specifically, when Synergy code opens an ISAM file, some consistency checks are performed between the index and the data file in order to detect a partially completed ISAM operation. If SDBMS detects an inconsistency, it will go rebuild, recover, resync that file back into a working state. This relies on having a local XF server service running to guarantee that the recovery operation will complete successfully, even in cases where there might be an impatient user that's actually driving that file open, or a process timeout in the case of something like XF server plus call. This does not require you to generally use XF server though. This is just handing off the recovery operation to be done in the XF server process. Having this ability starts to matter much more in an environment that is otherwise tolerant of failures that would have resulted in significant service disruption in the past. You don't want to have all of these services stay up, but the data files have something corrupt in them, and then a user, an admin, has to connect in, figure out what file has been corrupted, look at logs, dig through it, actually do the recovery, wait for the recovery to complete, and then let users back in. You want that process to be as automatic, quick, and pain-free as possible. Also, as part of this work for resynchronizing the index and data file, we've made it possible to do an index rebuild without kicking users completely out of the file or your application. So it makes it a lot easier to keep your ISAM files in tip-top shape, and that makes a pretty big difference in 24/7 type environments. So we know Synergy has given us the building blocks to keep our ISAM files healthy in this environment. Where do I actually put them? Like the files on disk. Is there some kind of Kubernetes file system that I'm supposed to be using? It's not exactly a file system, but there are a bunch of connectors and offerings from cloud vendors and hardware storage vendors. And fundamentally, you're using what are called persistent volumes. But that's really just a management layer over that underlying storage mechanism. So they're the ones that are doing the storage, and then it's exposed to Kubernetes. The most common approach is to just use the regular old disks that cloud vendors offer. So that's things like an Azure persistent disk or AWS EBS or Google persistent disk, or the SAN that you have in your existing data center probably. These are all great for a single data center setup. They're generally either fast or can be configured to be fast. And if you're not worried about staying online during a massive regional disaster, this is probably good enough. It's cheaper and faster, so stay in this space if you can help it. But what do you do if you have to be able to stay up in that regional disaster scenario? Well, there are some cloud-specific requirements that we aren't really going to go in here because they should be handled by cloud specialists and aren't Synergy-specific. But as for the specific Synergy data requirements, you can use on Azure and GCP, you just toggle during disk creation to say that your disk is replicated to a separate region. And for AWS, the easiest Synergy safe way to do this is actually to use their FSX Lustre storage instead of EBS. There's definitely a latency cost associated with these regional disk types. So keep in mind that for things like temporary or regenerated files, that you wouldn't want to use this kind of storage. When we run the thought experiment trying to figure out what issues we're going to have in an environment where you keep users away from sort of administrator command prompt access, a few big Synergy things pop up. If I've containerized my Synergy application, stripped it down as small as I can get it, how and where am I supposed to get these Synergy utilities that I have relied on for years? Well, the easiest way is by building a utility image that can either be run using something like kubectl run or kubectl debug. I have a demo showing this with isutil, but the technique applies equally well to running utilities like fconvert, isutil, or ctutil. Basically, we start with a super cut down Alpine Linux image, add in some very basic compatibility libraries, and then extract the specific utility we want from an already existing Synergy install image. This might sound complicated, but it's really just a couple lines of Docker file that I'll show you in this demo. All right, let's walk through just the basics of creating a utility image for isutil and then attaching it into our Kubernetes cluster and making sure that we have access to data while we do it. So the first step here is we have a Docker file, and it's pretty small. So it's a multi-stage Docker file. So I'm taking files from an existing Docker image that we've created elsewhere. So this is a Synergy 12.1.1 image. It's full size. It's like 500 megabytes or something like that. And we're pulling from it just the isutil. So we're taking that isutil and putting it into bin so that it's really easy to use from the command prompt. And since we're based on Alpine, we have to add in some additional compatibility libraries in order to make sure that we can actually run normal, not made for Alpine software. And I've picked Alpine because it starts out at less than 5 megabytes for the image. And you'll see what we end up with after this Docker file is made. So I can say Docker build, and it will build this Docker file. And go Docker images, we can see this image that I just made was 9.34 megabytes. So quite a lot smaller than the 577 that a full Ubuntu container image plus a Synergy 12.1.1 install would actually take up. Now on to sort of the heavy part, attaching this thing to Kubernetes. So there's quite a lot of ugly JSON in here, but it's pretty much standard between runs. So I have one volume and I'm mounting a particular image. So I've picked my isutil image that I previously uploaded to my public Azure container registry. So that has our isutil in it, and then we've specified the persistent volume claims that we want to actually use. So if I go run that, it's going to create this container. It'll be very short-lived. So once I exit, it'll get deleted. But on the inside, we have our RCC data mount. It is in there. And And I could go into something like IT01 here, and there'd be a bunch of ISAM files, and I could run -util -l because I want it cooperative, and we're just gonna try and look at contresv. Indexing is complete, and there's nothing wrong with the file. So you could imagine that would be useful in a production environment if you have cut down your images to contain just your running executables. So this is a way to have a utility image. There's a slightly different answer for tools like Monitor. Because of the kind of inter-process calls that are required, they will definitely need to be running inside the container namespace of your XF Server service. So if you have a container that's running XF Server, you will have to be able to identify that container by its name, and then you can use kubectl debug, provide your utility image, and you can run Monitor and solve whatever problem it is that you're looking to deal with. That's a similar way you can do things like attach with the debugger inside of your process namespace. There's a lot of tasks that you can perform using that kubectl debug and a utility image sort of pattern. Do keep in mind, though, when you're attaching to a pod, that any changes you make to the system won't persist the next time you do a deploy. So make sure you aren't attaching to perform configuration kind of steps. Those will get undone or not reconstructed if anything happens to the node or if you deploy a new version of your software. So just never do configuration steps manually in this kind of environment. So all the cool kids seem to be running load balanced, multi-node distributed Kubernetes services. Yeah, it looks like sort of a holy grail of uptime, but there are significant financial and maintenance costs that go along with it. It used to be that if you wanted 192 CPUs and a terabyte of RAM, you had to have multiple nodes. No longer. You can just ask your cloud provider for one of these super large VM sizes and get all of that on a single box, no problem. 192 CPUs and a terabyte of RAM can run some very big applications and run them very fast with much less management overhead. Running in the cloud with that sort of size really reduces the danger that your one giant VM goes down, thanks to live migration from one physical server to another. Beyond the physical constraints, your containerized applications can be packed into this kind of environment to be able to still apply patches in your containers without large service windows. So containers, cloud, and VM tech has really made this much more attractive than it used to be. But this slide is about what do you do when you absolutely, positively must have multi-node active-active. So inside of a Kubernetes environment, for us anyway, there really appears to just be one answer for multi-node synergy data files, and that's Lustre. So Lustre is an open source clustered file system for Linux that's commonly used in the HPC world in order to support very high performance, very large file systems. Conveniently, this is starting to get packaged into much more business-friendly deployment options. And I have a demo here that I'll show off some of the moving parts and then spin up some Synergy code running on multiple nodes so you can get a feel of what the process is. So the first step in having a multi-node Synergy running in Kubernetes cluster is to actually have multiple nodes. So to do that, I've used Terraform. So Terraform is a infrastructure as code project that will let you set up all of your infrastructure the same way consistently. So you don't have to go through a UI and press buttons or write an imperative script. If I make some little change, it will apply that change to get the state of my cloud resources to reflect this, rather than having to tear down and rebuild the entire thing. like a script would have to. So Terraform is very useful in this particular environment, and it's not too bad. It's not too hard to figure out. Definitely some complexity in here, but just because there's so many moving parts in setting something up in the cloud for Kubernetes. So this is in particular AWS. So this is their Elastic Kubernetes service. And we're going to create 3 nodes in 2 different availability zones. The nodes are relatively small, but they're just large enough to run our particular workload. And then we will eventually have persistent volume claims out to our Lustre backend, and we will run our RCC application on that set of nodes that we've created. All right, so the Terraform scripts have already been run at this point, and you can see that we have some nodes in our cluster that we're attached to. We have 3 nodes, and they are in US West 1A and US West 1C. So that's where all of our pods are going to end up running. So the first thing that we need in order to have our Lustre is we need a storage class. So I have this YAML manifest here for the storage class that and it basically, it's pretty AWS specific, but it's just setting up the basic parameters and saying, what the network is that's being used, what kind of Lustre deployment is it, what the expected performance throughput is, when there's maintenance, what the versions are, and that sort of thing. So that exists out there to give us the starting point for Lustre. And then there's the PVC, so that's the persistent volume claim. So that gives the name and sort of the size, the actual storage that's happening. So the storage class says what kind it's going to be, and then the persistent volume claim uses that kind and actually makes the storage. So we're going to use that PVC inside of our actual RCC client deployment. And so that is yet another YAML file. So it's a set of deployments. It's many deployments. Up above, there's the RCC API, and there's the RCC engines. And right here on screen, we have the RCC client itself. So this is the access that's done over SSH into an interactive environment. So what we're doing here is we're setting the replicas to 3 because we want 3 distinct hardware nodes to be running these containers. We're setting up some ports, and we're setting up some environment variables and where data comes from. And crucially, we have the persistent volume claim being set. And we are telling Kubernetes where that persistent volume claim is supposed to be mounted. So I've already added all of these manifests in. And so we can see when I get pods, all of them are running. We have 3 RCC API nodes, pods, 3 RCC client pods, and we have 1 RCC engine pod. The engines in this particular application wouldn't make sense to have running across multiple nodes simultaneously. They're sort of inherently serial, at least amongst the individual engines. So those are restricted to only run on 1 node at a time on purpose. So we have these pods, and for demo purposes, to make this a little bit easier to set up, this stuff is all running in AWS, but I can forward some things around for development and demo purposes. So I have set it up to point to a particular pod just so that I can connect in and show you I'm really connecting to that pod and not to the same one multiple times. So I have a port forwarder on 2022, and I have a port forwarder on 2023, and they point to different pods. So I can connect in over SSH. And again, this isn't really localhost. This is just going across that port forwarder. And inside of the RCC app. So I can log in. Go take a look at some leads. Go look someone up. See if I get this right. Change this one and commit it. So that's updated this particular lead's last name. And if I connect in on the other node, we're going to see that that actually did take effect. So this is a completely different machine, but connected over the same Lustre cluster. And I can see when I select this thing, it's now this person's last name has been changed from ASDF to ASDF PDQ, and so it's matching from one node to the other. I'll just exit out of that. So that is the RCC API. Or that is the RCC client running, and the engines are running behind the scenes to service those requests that I just made through the client. So at this point, you've seen me log in over SSH and interact with the RCC application directly. Normally, that would have been over a load balancer, but for the purposes of this demo, we're going straight into individual nodes, and we're going to continue that theme here with the HTTPS API as well. So I've done the port forwarding trick. So this is not actually localhost. This is one of the nodes out in AWS. And so now I can log in and I can get an API token. And I'll go shove that into some bearer token location over here. And now I can hit RCC API and get back data. So this is kind of the optimal way that people would interact, that software would interact with your software in a clustered environment, because the connection doesn't have to stay open. If something moves from one node to another, or one node goes down and a new node has to come up, this does not notice. If you're just asking for HTTPS calls, no one will be the wiser that a node went down and came back up. And that's really what you're hoping for in a high availability kind of environment. If you're entering this multi-node active-active world, there are some things to watch out for. This is a very general but very strong warning. Do not trust NFS with multiple nodes and synergy data. There's a whole heap of providers that make claims like POSIX file system support in their NFS-based solutions, and they will definitely corrupt your Synergy ISAM files. The only NFS provider we found that actually works is the one that ships inside of Windows and as part of the Azure Files NFS provider. It's really not very fast, so we wouldn't recommend it for anything sizable that you're trying to do in production, but at least it won't corrupt your files. So I may have scared you off using active-active for HA, but you probably still have requirements from your C-suite that say application must remain available or return from failure quickly. Containerization, cloud providers, and Kubernetes have your back here. Even if you're running all your pods on a single node, that doesn't mean you're tied to a single piece of hardware. If you've got your data on a persistent disk, you've got your ISAM files set up to be resilient and automatically recovered, that means you can basically have a hot standby without actually paying to have a hot standby. So imagine something catastrophic happens to your node, however unlikely that may be. The pods all die. Kubernetes notices this, adds a new node into your pool from your cloud provider because you've set up the scaling for your pool size. And the new node quickly loads up your containerized application, attaches to the persistent volume where your data is located. Kubernetes load balancer moves to the new node and service is restored. If that catastrophic thing caused damage to your ISAM files, they'll get recovered automatically. And in most cases, you'll look like a star because your Synergy application just survived some terrible potential outage. So even if you have great, highly available setup, backups still matter, and the kind of backups you're using will dictate the kind of results you get when you restore from those backups. Ideally, just like in a non-container environment, your backup provider should be taking application-consistent snapshots. We have scripts for Linux to help you plug into those mechanisms, and we have a service for Windows to do the same. Specifically, in this environment, there are 3 major providers that expose hooks that allow for application-consistent backups. So there's Veeam, which is our sort of preferred on-prem backup provider. Portworx does this. NetApp also does this. Application-consistent backups basically means that your application pauses for a very short time during the backup to allow ISAM operations to complete before the snapshot is actually taken. We use this window plus syn backup to ensure that your ISAM files have not actually been partially written, that everything has been completed and pending operations are out of the way. Additionally, inside of your application, you can check for these pending operations and ensure that you don't start something like a day-end process that's going to write a whole bunch of records, and you wouldn't want your backup to be half on this side and half on that side. But if your backup provider doesn't support these kind of hooks, they likely at least support an API for triggering these snapshots. That means that you can potentially roll your own. Set syn backup, call the API, turn syn backup off. That's the general gist when you're DIYing this. It's obviously not as clean or as fast as with integration, but it can get the job done if that's what you're working with. So if you can't have application consistent backups, what can you do about it? Well, for starters, you can spin up a tiny ISUtl pod to verify the consistency of your snapshot after it's been taken. So now that we've got these utility pods that just have the Synergy utilities that we want, you can hook them right up to your backup provider's snapshot and go run against it and say, was this snapshot good, in an automated kind of fashion. So this is made quite a lot easier in a Kubernetes type environment because it looks just like a live file system when you attach the persistent volume. And definitely an important topic. Obviously, if Synergy licensing doesn't work, you won't be able to do very much with your Synergy application. In order to support these scale up down type scenarios, we needed to separate the licensed server from the running pods. Before Rev 11 licensing, if you wanted a Synergy application running on Linux, you needed to manually install keys directly on that particular running image or physical machine. If you were in an environment with hundreds of images, good luck managing all of that. Now, after Rev 11 is out, Linux can just point to another license server. This does require subscription licensing, but that's not exactly a high barrier to entry at this point. And currently, we require that the license server that you point to be running on Windows. It's just a technical limitation that we have right now. If you want to reduce the risk that something bad happens to this Windows license server, you can leverage our backup license server functionality and talk to sales about how to make that happen in your environment. If you're going for high availability, it removes one more single point of failure, so it really can be worthwhile. And I think you see where this slide is going. Is this Linux only? No, this isn't Linux only. This does actually work for Windows as well. Those containers are a little bit bigger than Linux containers generally. So I have a demo where I'm going to show some basic containerization and running some Synergy code on a Windows container. All right, so what I have here is a Windows Server 2022 virtual machine. And inside it, I've enabled the container workload for Windows so that I can run Windows containers with process isolation instead of just Hyper-V isolation. So this Docker file, the purpose of it is it's setting up a environment based on Server Core Long-Term Service Branch 2022. It installs all of the Synergy requirements and it points at a license server that I have locally. It installs the Visual Studio build tools and all of the workloads that are going to be required for me. It installs using Chocolatey, 7-zip, and .NET SDK and Git, because I'm going to use those later on in this Docker file as well. I go grab some build tools that are essentially just extracted from a Synergy. I unzip them and put them in the appropriate places. And then finally, I clone my Harmony Core Git solution from GitHub, and I run a Visual Studio command prompt, and I build and publish the services host project inside of Harmony Core. So that just set up a whole load of basically baggage for an image. So each one of these run steps is creating a new image, and they layer on top of each other. So by the time I get down to the bottom, I have all these images and all these extra files, and it's much larger than it needs to be, especially since when I go to actually run this Harmony Core web service, I'm not going to need Visual Studio build tools, for example. So what I do is this is a multi-part build, and so I just start over. So I start over, and then I only do the things that I absolutely need in order to run my Harmony Core web service, which in this case is I need to go get the Visual C++ redistributable for 64-bit. And then I go copy from my prior stage the contents of the publish folder. I go grab a PFX file for HTTPS, and I copy the sample data also from the first stage. I make sure that my environment variable is set up for Synergy licensing so that I can do that without having Synergy SDE install present. And then I expose my HTTP and HTTPS ports and do some configuration with ASP.NET Core. And finally, I let Docker know that when this image is run, what I'm actually asking for it to do is go run cpublish services host.exe and just, let it run. So let's see what that looks like. I've already done this on this machine, so it should be cached through pretty much all of the build steps. But you can see steps 26. There's 26 steps involved in this. Each one of those was a new image. So we've ended up with a much smaller end result because we skipped all of the extra stuff, only grabbing the files that we actually needed. So if I want to go run this in this very sort of small environment that I have, I can just run docker run it interactive, give it a port mapping. It's just 8086 to 8086, and specify the container image hash that I just got popped out. It'll take a moment to spin up. And then we'll see our familiar Harmony Core startup text as it spins up. And now it's listening. Now I should be able to go curl my way into that data. And so I have. So, bunch of command prompt JSON that's good enough for a containerization on Windows demo. And who has the first question?
We did have some questions already from Chuck, and he's been doing a back and forth with Jeff. So those who have their chat collapsed or just have been like listening to this, we'll go. I'll just kind of say those out loud to hopefully get the gist of it. So Chuck was asking if the RCC demo, if the data is distributed on a distributed file system or a shared XF server. Jeff, it says that the demos are. None of the demos are using XF Server. They could run that way, but it's faster and has less required management if you run the data run with data attached. Then Chuck was asking about if any of these, if Synergex is going to have verified publisher images available on hub.docker.com. And it looks like as far as the images on hub.docker.com, Steve has his images located there. And if you have specific needs in this space, you can reach out to your sales rep to go over your scenarios that you need in depth. And then the last one, well, then there was some discussion, but then Chuck was asking if there's a separate session developing Synergy apps targeting containers. On that one, looks like Steve's session might be covering a little bit of that with Synergy applications. Most of the way there. That's the next Wednesday, the first session on the 28th, for those who don't know, on that one. Then it looks like, Jeff, there was some discussion here about Windows versus Linux containers. And you said in the demo, and Chuck saying that they're ginormous, like compared to a Linux container. Windows containers are much larger. Looks like
certainly in comparison to that Alpine image that I had, 9 meg. Not even I could have gotten it smaller than 9 megs if I tried really hard.
Lots of effort.
Yeah.
You did say that they're good for CI/CD, or is that I'm assuming
CI/CD.
Yeah.
So if you're trying to build your application, like in your internal build pipelines, and today you use Windows to do your builds, then Windows containers can be a really smooth transition. And the fact that they're a little bit large and they don't have a super amazing networking story in comparison to the Linux stuff doesn't really matter to your CI/CD pipeline. So it can be a really good fit there. It's not impossible to get reasonable sized Windows images depending on what you're doing. They're never going to be 9 megs, but they don't have to be plural gigabytes.
Right. Any other advantages to Windows containers, or is that's like the big one?
Compatibility is the main one. If it weren't for compatibility, the Linux ones are path more trodden, and so you should probably stick to that.
Yeah. All right. Awesome. Chuck was also asking, will the YAML configs be uploaded to Git?
Some of them already are. So we have a GitHub repo, Synergy Containerization Helpers, I think it's called, that has sample scripts and some sample YAML files and some sample Docker files. And also in Steve's session, he'll have a much more complete full set of Docker files for Synergy applications generally.
Awesome. Once again, that is the developing Harmony core services on Linux and in containers that's the first session, Wednesday, September 28th. So I on that one. So also Eric has a question. I might generalize this one a little bit, but if we're looking for documentation on the basics of doing this, where would you suggest starting?
Well, the starting point is right here. There will be actual documentation on this. There's not a whole lot of mentions today in Synergy docs of containerization. That will change going forward. Right now, reach out. If you want to do this, reach out, and we'll provide you with specific examples and or assistance where necessary.
Is there a specific place to reach out on the web for you and Steve, or just go to Synergy support at this point?
Sales rep, or you can email me. I mean, first name dot last name at synergex.com.
Right.
You can get a hold of me.
Oh no, that's our company's secret, Jeff. No,
very secret. No one ever knew.
Super secret. No one saw the pattern. Yes. All right, Chunk's got another one. So, any other customers running with containers, or would he be the first? Because it sounds like he's very interested in getting this going. So,
so I can think of one customer that was doing this in a somewhat less than supported configuration, like 4 years ago. I don't know that they do it today. So I'm not sure if you'd be the first exactly, but you'd be the first in the well-supported, thought-out version of it from a Synergy perspective.
Awesome. I was kind of wondering, Jeff, so I know the RCC application, and I know Kubernetes and all that kind of stuff, and I've learned more, from these sessions, but was there any sort of changes you had to make? What kind of changes did you have to make to the RCC application in order to get to run in Kubernetes?
So there weren't a whole lot of changes that we had to actually do to the RCC application. There was a bunch of configuration changes that had to be done, and subsequently, there have been some changes to the application to make this a little bit easier, just because RCC, the version that we have, normally lives its life on Windows. And so there were some pathing things that have become a lot easier now. But that's the kind of class of stuff. If you don't normally run on Linux, you probably need to do something in order to be able to run on Linux. But there's not a whole bunch of stuff that you'd be doing, and it certainly wouldn't be Kubernetes specific. It's just, as far as your application is concerned, when you're containerized, you're just pointing at data, you're running code. It's not that different from full-sized manually managed servers.
So mostly like environmental based type of stuff we're talking about, like just getting it all to fit inside of that container in a application sort of way, right?
Yep. Yeah.
All right. Sweet. Jack's got another one.
Yeah. I'm not sure it's exactly rainbows and unicorns. Containerization is containerization of your application is you have to collect all the bits. That's really the hard part. So knowing what all of them are and knowing where all of them go and standardizing that and not forgetting about any of them, that's the hard part. So not rainbows and unicorns, but that's really just because all of our applications have been around for a very long time and they have craggly bits in the corners. So you gotta get those craggly bits into the container in order to make it work.
It's like doing dishes, and there's like the little bit of gunk in the corner there. You have to do a little bit of scrubbing to get it out, huh? There you go. I was wondering, and this might be good for some of us, who are going to try and be doing this. In terms of the license server, why does it have to be? Why does the license server in particular have to be from Windows?
So right now, the only place we have a IP license manager is on Windows, and currently installing, configuring licenses is not a super automatic kind of process. So we have to do this over IP, just generally. Specifically in a Kubernetes environment, if you're not worried about nodes going up and down, like if you're in your own data center, you can launch your nodes and run Synergy licensing on the node, and then share the IPC space with your actual Synergy containers, and they will use that license server. But in a cloud type environment, that gets pretty iffy, and so doing it over IP is a must there. So that's why. I mean, it's just it's a current technical limitation that it's specifically Windows. But as with so many of my other comments here, reach out if this is an important scenario for you, so that we can prioritize things appropriately.
Yeah. It's actually already come a long way, because I still remember like trying to do Docker's containers and trying to figure out, okay, now how do I get this all licensed? Like, it sounds like it's much more obtainable now without doing all sorts of, like you said, unsupport configurations type of stuff. So good deal. All right. Do we have? I don't see any more questions unless I'm missing any from the Q&A. Any last comments that you got with this, Jeff? That's oh, let's see here.
Gordon says, Chuck, will you be giving a session at next year's conference on what it's like to be first and how you got on?
I mean, contact your sales rep. There you go. So we'll go ahead and end this. Thank you, everyone, for joining. So be sure to join in a few minutes for our next session, which is leveraging web services for UI with Rachel Gibson. I'm looking forward to that one. It's going to be awesome. So with that, have a good one. We'll see you then.